Okay, this is our video lesson on how to name the trig functions if you're given a graph. So I'm taking, this is from 8.1 to 8.4 practice, question 21. And I just want to take this function, and because there's a lot going on with it, and name it 4 different ways. So first things first, it's very nice to collect some information about this function, the amplitude, the frequency, the period, and the range. In fact, I really probably could have asked you to find the midline first. The midline is helpful. So if I'm looking at this function, I max out at 1, and I min out at -3. So my midline is right here. And again, like I said, you're maxing out at 1, you're minning out at -3. -1 is right in the middle. So my amplitude is the distance from the midline to the top of the function, which you can easily see at this point. That would be 2. Most of you are good at this, so I hope this is just review. Frequency. Frequency is the number of curves, or the number of cycles that we see in 2 pi, or 360 degrees. And right now I see 1 cycle, 2 cycles. That's my frequency. That's pretty easy to see from the graph. All right, the period is the length on the x-axis that it takes for 1 cycle to emerge. Meaning, if I look at the yellow cycle, for example, this yellow cycle, it takes me from 0 to pi to make that happen. So my period is pi. Another way to get the period is to say, well, period is 2 pi, that's 360, divided by the frequency, which is 2, and then I can get the pi that way as well. The range of the graph, well, my minimum point is -3, my maximum point is 1, my range is -3 to 1. And notice, -1 is right in the middle, and that's the midline. Okay. Now I want to erase some of this stuff, but I'd like to actually keep the midline. So I'm going to erase it all, and we're going to start. Oh, the midline stays. Perfect. Okay. So here's what I have now. Now I want to get names for this function. So a couple of things. What you might want to do, first of all, is take a look at the vertical shifting, because the vertical shifting doesn't change very much. So if I look at the vertical shifting, normally for sine and cosine, the midline is at 0. Okay, normally the midline is here. Now my midline's at -1. So what that means is everything has shifted down 1 unit from the midline. So if I think of sine and cosine, again, my midline for sine and my midline for cosine are at y equals 0. So everything is shifted down 1 unit. So when I look at my vertical shifting, I want to have a vertical shift of -1 no matter what. My amplitude actually gives me the stretch, the vertical stretch. So I know my names are going to start with, so if I have f of x, for example, my names are going to have my amplitude times a trig function -1 for my vertical shifting that you can see from the midline. So my goal is really to fill in what's in the box. And how can we do that? Well, here's what we can do. The first thing I'm going to do is I'm going to look for a sine curve. A sine curve starts at the midline, goes up, comes back down through the midline, and ends at the midline. So my sine curve starts and ends at the midline. Well, where does it happen on my graph? Well, I could actually start at 0, go up, down, and there's 1 cycle. That's a cycle that looks like a sine graph. The question is, how am I going to transform the regular sine curve into that? So I hope we would all agree. My regular sine curve looks like this. Okay, here's a regular old sine curve. And I needed to make that phase of sine, or that shift, that graph of sine, look like the blue. Okay, well, obviously I have my vertical stuff, which we basically just talked about, how I'm going to move it down 1, and then I'm going to stretch it vertically. So actually, I should probably stretch it vertically first. Excuse me. Let me stretch it vertically first, and then move it down 1. So now it's perfectly in line. So that's my vertical stuff. But then I have to look at what I have to do horizontally. Normally, sine goes from 0 to 2 pi, but this cycle goes from 0 to pi. So I have to take this sine curve and make it into this. And what do I have to do to get there? Well, I can cut the period in half. In other words, I'm doubling the frequency. In other words, what I'm going to have is I'm going to have 2 sine of 2x plus 1. Because what I have to do ultimately is I have to divide the range by 2. I have to divide the range by 2, so I'm doing the opposite of that inside. So this one name for this function would be f of x equals 2 sine of 2x minus 1. Okay. Now what I would like to do is name this with a cosine name. So again, I'm still going to have my same vertical stuff. I'm going to have 2 cosine of something. That's what we're going to try to figure out now, minus 1. Okay. Well, cosine. So I'm going to look for somewhere on this graph that starts high, crosses the midline, goes back through the midline, and ends high. Okay, here's my midline, and I'm starting high and I'm ending high. Well, I can find that in lots of places, but here's one place I can find it. We'll work on this phase. I'll start at pi over 4. I'm crossing my midline, going to the min, and I'm coming back up to the max. There's my cycle. Now, again, cosine normally does this. It starts at 1, goes down to 0, goes down to negative 1, and back up. Now we know how to vertically shift this. So first things first, I'm going to stretch it vertically. Stretch it vertically. Okay. Stretch it vertically. Okay, and move it down. So here's what I had. This is just the vertical stretch, and I move it down 1 unit. That's where we're getting the 2 is the vertical stretch, and the 1 is the shift that we have to move down. Now, ultimately, I have to get this cosine graph, the regular one, to match with the blue one. Well, how am I going to do that? Well, the easy way is to say, all right, you know what? If I'm looking, I have to scrunch this function up. I have to cut my period in half. Well, if I do that, let's see what happens. If I do that, I'm cutting my period in half. I go from this graph to this graph. See, watch it again. This graph, if I cut my period in half, I go to this graph. Because remember, the 0 point doesn't move. So the point at 0, 1 stays at 0, 1 when you divide 0 divided by 2. So I end up getting this. Now, that's not good enough. Hold on 1 second. I got to squeeze it a little bit more. Okay, there we go. I get that graph. But that graph is not going to match perfectly with the blue. It's got the same shape and it's got the same size, but it's not in the right location. So what we can do with that graph is move it over. I can move it pi over 4 to the right, and I'll match perfectly with the cycle that I want to get. So just to reiterate that again, cosine normally looks like this. We said to get it to look like the blue graph, we can cut the period in half, okay, which gives us here, and then move it pi over 4 to the right. So I'm going to write that down actually. I'm going to write this down. I'm going to say firstly we divided by 2. And secondly, we shifted pi over 4 to the right. Those were the transformations that we did to get the the yellow graph to become the blue graph. Now, what's going to happen when we go inside this function? Well, what's inside the function has to be the inverse of all of this stuff. And that's how we're going to do this. Because ultimately, we have to undo what we did to get the inside stuff for a transformation. So here's what we're going to do. We're going to construct the inverse of these steps. So I'm going to start with x. That's my first starting point. Well, in order to invert, I have to do the opposite steps in the opposite order. So my last step was pi over 4 to the right. So then I'm going to take my x and I want to subtract pi over 4. That's the inverse. Then I'm going to take that answer, and multiply it by 2. because that's the opposite of dividing by 2. Notice I needed parentheses because I want to do this step last and this step first to invert my function. And so now my transformation becomes 2 cosine of 2 parentheses x minus pi over 4 minus 1. And that graph would also give me the graph that we want. And that gives us 2 names. Not too bad. Okay. With those names down, we're going to try to get some other names. And by the way, just to take a look, you know, your amplitude is still 2. Okay, I hope you see that. Your frequency is still 2. I hope we see that as well. So those things should match up. Okay. Now I'd like to get a couple of more names, and these can get a little trickier. So let's say I wanted to start my naming not with positive sign, but with negative sign. So here's positive sign up in the corner here. Negative sign of x is just a reflection of that over the x-axis. So negative sign of x looks like this. Negative sign x looks like that. Now, negative sign of x goes down first and comes back up and ends up at the midline. So it starts at the midline, goes down, comes back up, and ends at the midline. So I want to find a cycle in this graph that does the same thing. So by the way, just to reiterate here, my new name, I'm going to have f of x. I'm going to use negative sign of x. And the amplitude and the frequency, the amplitude and the midline stay the same. So I'm going to have negative 2 sine of something minus 1. So the vertical transformations always stay the same. But now we're going to try to do this with negative sign. So I want to try to find a negative sign cycle in here. Well, here's one right here. I'm going down first, coming back up, and boop, there I am. Okay, so normally sign looks like this. Sorry, excuse me. Negative sign looks like this. It's normally what it looks like. And my goal is to make it look like the blue graph. So the vertical stuff is easy, all right? I stretch the thing out by a factor of 2 and move it down 1, and I look like that. Okay? That's the vertical stuff, and that was already taken care of. That's what the negative 2 and the negative 1 did. Now, ultimately, I have to get this graph to look like the blue graph. So what I can do is I can squeeze it, because it needs to be squeezed, into a period of pi, but that's not going to be good enough. So watch what we did there. We used to have this graph. That's negative sign, and we squeezed it down to get this graph. But that's not good enough. I have to then move that graph pi over 2 to the left. So let's just reiterate those changes. I have to, here's my original negative sine curve. I have to squeeze that down and then move it to the left. By the way, as we discussed in class, it's much easier to do the squeeze and then the shift. That makes life a lot easier. So here's what we did. We first divided our domain by 2, and then secondly, moved pi over 2 to the left. So I have to identify what it is that we're doing. And you know what I can do? I can bring in, you can do this with tracing paper if you'd like, or I can bring in transparency paper if you're not seeing it, or you can do this at the smartboard if you want to come after school or something to see the transformations. All of that is fine with me, just to get the idea. Now, I need to invert this. So I'll start with x. I have to do the opposite steps in the opposite order. So moving pi over 2 to the left, I will add pi over 2 to x. That's the opposite step. Then I'm going to take that answer, and instead of dividing by 2, I'm going to multiply it by 2. And that's my inside transformation. That's the transformation that will do the trick. By the way, if you're not sure about this, just remember something. You could plug in values and see if it works. So for example, if I plug in negative pi over 2 into this rule, That would give me negative 2 sine of 2 times negative pi over 2 plus pi over 2 minus 1. Negative pi over 2 plus pi over 2 gives me 0. And then I get sine of 0, which gives me 0. Multiply by negative 2, I get 0, minus 1. I'm right where I need to be. And you can always plug in values to see if these functions work. And some of this is going to be a little, you just have to kind of guess and check at it. Or just plug in, not really guess and check, but plug in a value and see if it actually works. Okay, we're going to do one more. And this time I'm going to name it with a negative cosine graph. And you're going to see we're basically doing the same steps each time, which is with a different curve. So back to my graphs up here. I have positive cosine of x. This was positive cosine of x. Negative cosine of x is reflected over the x-axis. So negative cosine of x looks like this. So negative cosine of x starts below, hits the midline, maxes out, comes through the midline, and ends up at the bottom. That's your negative, that's negative cosine. There's your negative cosine. And it goes through the midline, doesn't start at the midline. So I need to find a place where that happens. Well, here's a perfect place where it happens. I start at negative pi over 4, go up, and end up at 3 pi over 4. So there's a place where it starts. So, again, my vertical shift's not going to change. So I'm going to start with, this time I'll do negative cosine of something. I have my 2 for the amplitude and my minus 1 for the midline shift. Now, I need to take this. Here's my regular negative cosine curve. It starts at negative 1. Whoops, excuse me. If you want to make it that thick, there we go. Negative 1. It goes up to 1 at pi, and it comes back down. That's my regular old negative cosine graph. Now, what I can do with that is I can change the amplitude so that it matches the amplitude of what we have. I can shift it so you can change the amplitude and shift it down. That's the vertical stuff that we already took care of. Now the question is, how do we make it look like the blue? Well, again, I got to squeeze it horizontally and then move it. So that's what I'm going to do. I'm going to squeeze it horizontally. There's my horizontal squeeze. I got to go from 2 pi to pi, because ultimately that's my period. The period doesn't change, 2 pi to pi. And that's not good enough, because I ultimately need to shove this over pi over 4 to the left. So we're going to try that one more time. So I have my regular cosine graph. I'm squeezing it down to a domain from 0 to pi. Oops, sorry. Let me try that again. I'm squeezing it down to a domain of 0 to pi, and then I'm going to move it to the left. So one more time. Taking this graph, we're squeezing it down from 0 to pi, and then I'm moving it to the left. And now I have to do those steps. So first things first, what did we do? Well, we divided by 2. And then I moved it pi over 4 to the left. So now I have to go back, I have to invert that. So here's my invert, or my inverse. I'm going to start with x, and I'm going to go up the list in the opposite direction. So we're moving pi over 4 to the left, so I'm adding pi over 4. I'm doing the opposite. Then I'm taking that answer, instead of dividing by 2, I'm multiplying by 2. And this is my inside stuff. The 2 times x plus pi over 4 is the inside stuff. And that would be a fourth rule. And you could go on and on and on. You could get 5, 6, 10, 14, 95, infinite number of rules. Because these functions repeat themselves over and over and over again. But this is how to get 4 rules using sine, cosine, negative sine, and negative cosine. And I hope this was helpful. This is, as far as I can tell, and I scoured the internet for other ways and books to do it, I think this is the most efficient way to do these. And I think it's the most conceptual way to do these. All right? All right, thanks, guys.